Hi guys, and welcome back to Mindset Learn Extra Grade 10 Life Sciences. We completed the last session, transport systems in humans, and we looked at the heart and how blood circulates through the body. Today we're going to go a little further in this quest of ours through the body, through the transport system in our bodies. Today we are focusing mainly on the blood vessels, the lymphatic system, and diseases of the heart and the circulatory system. Let's get right into it. Remember, we spoke about the last time, we said that mammals have a closed blood system. In other words, blood leaves the heart, goes into blood vessels, and returns to the heart via blood vessels. In other words, the blood does not leave the blood system. And the cells and tissues are surrounded by tissue fluid and not by blood. In an open blood system, as we learned the last time, blood goes from the heart into chambers, and the cells and tissues are actually floating or bathed by the blood itself. Now, we do not have that. We have a closed blood system. Also, remember from the last time, A for away. All arteries carry blood away from the heart. All veins carry blood to the heart. And capillaries serve as a link between arteries and veins. But more importantly, the capillaries are very small structures that can reach areas where bigger arteries and veins cannot reach. Let's look at the structure of arteries, veins, and capillaries. A very simple diagram will explain the difference. An artery has an outer connective tissue with a thick layer of smooth muscle in this area. The vein has a very thin wall, and as a result, it has a large lumen. Notice in an artery, the lumen is smaller because the walls are thicker. A capillary, on the other hand, is made up only of an endothelial layer, a single endothelial layer. And we spoke about this when we spoke about squamous epithelial tissue. If we take a cross section through that, just through the wall, a very schematic diagram, we'll see there's the artery again. There's a smooth muscle here, thick smooth muscle. Outside is the elastin and collagen, the connective tissue outside. This one here, this red in this particular diagram, will be the endothelial cells and the lumen on the inside. That area there, lumen. When we look at the veins, here's a section to the vena cava, for example. You'll notice that the smooth muscle layer and the connective tissue are thinner. And it still has endothelial layer there, in that area there, and a bigger lumen. And finally, we look at a capillary. A capillary is only made up of a single layer of endothelial tissue. Now let's ponder a little bit about why the differences. The artery, we said, had a very thick muscular wall. The vein had a thinner muscular wall. The artery had a small lumen, and the vein had a larger lumen. Remember what we said on the functions of these blood vessels earlier. All arteries carry blood away from the heart. So they under pressure from the heart. As the heart beats, blood is pumping through them. So the blood that is found in an artery is under high pressure. Hence, it needs a thicker muscular wall to contain this pressure. And the vein, on the other hand, is bringing blood back to the heart. So it is not getting the pressure from the heart. So blood in the vein is flowing under lower pressure. Hence, it doesn't need a very thick muscular wall, and it has a large lumen. We must also add that a vein has valves. All veins have valves. Because there's no pressure coming from the heart itself, vein blood, or venous blood as it would be called, could backflow. That means go backwards instead of towards the heart, go back to the organ where it came from. So the valves, if you look at it this way, will prevent any backflow of blood because there's no pressure. And the capillaries, on the other hand, are made up of a single endothelial layer. This makes sense. Squamous epithelial cells makes up this endothelial cell layer. And we spoke about squamous epithelial tissue when we spoke about animal tissue. And you know, one of the location was inner walls of blood vessels, and it makes up a capillary. Its thin, flat nature obviously assists the capillary to be small and to fit into areas where arteries and veins cannot fit in. Moving on, there's a nice table if we want to tabulate the difference in theory. There we go. Arteries take blood away from the heart. Capillaries supply blood at tissue level, and veins bring blood back to the heart. Arteries have a thick middle layer of involuntary smooth muscle. Capillaries have a single layer of endothelial, and veins have a thin smooth muscle layer. Arteries have a narrow inner layer of endothelium, and capillaries, they're only made up of endothelial, and the veins have a larger diameter of the inner cavity lined with endothelium. Arteries are situated deeper in the tissue to maintain body temperature. Capillaries are made only at tissue level, and veins are nearer the surface of the body to release heat. Arteries have no valves except in the base of the aorta and the pulmonary arteries, as we discussed the last time. Capillaries have absolutely no valves, and veins, all veins have semilunar valves. Blood pressure is always under high pressure in the arteries. Capillaries also under high pressure, and in the veins it's under low pressure. In an artery, we will be able to feel the pulse as the blood flows. It's obvious because it is coming from the heart. As the heart is beating, the blood in the artery is flowing. So therefore, you'll be able to feel the pulse in an artery, not in a vein. Capillaries have no pulse, and no pulse in the vein as well. We're talking about blood vessels. Now we move on to blood itself. And we discussed blood not in too much of detail, but we discussed blood under animal tissue. Blood is also a form of animal tissue, connective tissue. It is fluid in nature. 90% of the blood is made up of water. The plasma is made up of water. 90% of the plasma, the liquid portion of blood, is made up of water. And in this liquid plasma, we find various cells. If we look at it, these cells are called the hemocrit. An interesting fact, about 5.5 liters of blood flows through an adult at all times. The pH of blood is plus minus 7.4, and the hemocrit is made up of red blood cells, white blood cells, and platelets. Interesting to know other names for these as well. Red blood cells are called erythrocytes. White blood cells are called leukocytes. There are various different types of white blood cells, which we discussed under connective tissue, and blood platelets are called thrombocytes. It's interesting to know the other names in case these names crop up in a paper or in a textbook, and you need to know that an erythrocyte is just another name for red blood cells, leukocytes, white blood cells, and thrombocytes, another name for platelets. All these different types of cells are flowing in the blood, and each of these cells have different functions. For example, the red blood cells transport oxygen and carbon dioxide. The white blood cells, so this is the transport the gases, oxygen and carbon dioxide. The white blood cells are involved in defense of the body. The blood platelets are mainly involved in clotting of the blood when bleeding occurs, so that the blood becomes thicker and it forms a scab, so that the blood stops flowing and you lose less blood. Certain people have a lack of that factor that initiates the blood clotting process. We say that they suffer from a condition known as hemophilia. You will learn more about hemophilia if and when you get to grade 12. When you do genetics, there's a special section dedicated to hemophilia and how it is inherited from one generation to the next. What are the symptoms? What are treatment, etc., that you have to worry about in that case. A little diagram just to show you a sample of blood, 600 times magnification, and as you can see in this particular diagram, you're seeing mainly the red blood cells here, there, all red blood cells. The leukocytes are not very apparent in this diagram here, but there's one there, we can see clearly, and if we go down, there's a red blood cell as well. So those are the different cells that we'll find in the blood. Now, let's move one step further. We all have blood in our body, and all our blood is made up of plasma, it is made up of platelets, it is made up of erythrocytes or red blood cells and leukocytes or white blood cells. However, not all our blood is the same. Like I said, they have all those components, that's the same. But we talk about, and you hear people talking, what is your blood type? So in this way, different individuals are grouped according to the type of blood, and these bloods are grouped, or we say that we have different blood groups. Now this is important to know, and if I have to, if there are many of you watching, and if I had to ask you, and if I could see your hands now as I spoke to you, and if I told you, those of you who know your blood type, put your hand up, I am sure there would be few and far between. Most of us don't know our blood type. Now, why is it important to know your blood type? Should you be involved in an accident, for example, and you need blood, then obviously, if they don't know your blood type, then they would have to test your blood and then determine your blood type before they give you blood. Whereas if you have that information on hand and you give it to the authorities or the health services that are helping you, then obviously it speeds up the process of you getting this blood. Now that's the way we need to think. So let's look at the different types of blood groups and how they are made up, and also how we symbolize them in terms of genetics. So when we're looking at those blood groups and transfusions, they say when a person loses a lot of blood during an operation or of an accident, blood must be replaced. In other words, he must get some blood donated to him. A blood transfusion is when blood is taken from one source and placed into the recipient via a vein. In other words, it is injected into the vein and the blood is then transferred to the recipient. In many cases, blood is donated on a regular basis by certain people, and the blood is stored in blood banks. You'll notice regularly advertisements asking you to donate blood. People go to schools, etc., to ask learners above 15 years old and obviously of a particular weight, and your blood will be tested and screened whether you are suitable candidate to donate blood. These are necessary measures we need to take in a country where there's lots of accidents and there's lots of operations taking place, and therefore lots of people need blood at regular intervals. So the more blood we donate, the more there will be in storage. So one day when we need it, it'll be easier for us to get this blood as well. They are the South African Blood Transfusion Services make regular visits to schools and communities. So make yourself available. At the same time, you'll get your blood tested. They will even tell you your blood type, etc., etc., etc. and you will know whether you have any deficit or any problems in your blood, so you need to take measures there with it as well. So the donated blood is tested to check that it is not infected with any antigens and also determine the blood type, because it's no sense taking a whole lot of blood and we don't know what type it is. What's the sense? We just take all this blood and we put it in packets and we store it. Now when we need blood group A, where are we going to look for it? So all these things are done in a scientific manner. We take the blood, they test your blood, they label it as A plus, A minus, B plus, B minus, AB plus, AB minus, or O plus, O minus. It all depends on the type of blood you have. In some cases, especially when a blood type is rare, a family member is able to donate blood directly to the recipient. In other words, if a member of your family has a problem, you can help your family member directly. If blood is not compatible with the recipient's blood, the donor blood will clot and can cause death to the recipient. Now, can you see how important it is for you to know your blood type? Because if you get the wrong blood type, it is a serious problem, because your body will fight that blood and it will clot because it will consider this blood to be foreign. Whereas if it was the same blood type, then your body does not have any antibodies to fight the same type of blood, because your body knows this is not enemy, it is friend. This is a clear diagram showing you when blood is donated, how it is stored in these packets and labeled, etc. And you can see all the pipes in this area here. These pipes, some of these pipes will be injected into the vein, and from there the recipient will receive blood. Now let's look at this interesting table dealing with the blood groups, as I said earlier. It's important to learn this from the start correctly, so that when you do genetics in grade 12, at least you'll have an idea as to how to work out problems on blood groups. Let's look at the table. The first blood group we have is A. This blood group could be either, we would say, homozygous A or heterozygous A. As you can see in this case, homozygous, that means they're the same. So it's IA, or the person can have IA with a little dot I there, indicating a heterozygous. Don't worry too much about homozygous and heterozygous. You'll learn more about these things when you get to grade 12. But these are the combinations. Now look at the type of blood that a person that has blood group A can get. He can get A and he can get O, because his blood will be able to accept O blood as well and A. Why is this so? Because he does not have no antibodies for A and O, but he has antibodies for B blood. So if he gets B blood, then his body will react to that and the blood will clot. Person that has B, similar to A, IB homozygous, IBI heterozygous, and this person can receive B and O. Notice again, here this person has no antibodies for B and O, but has antibodies for A. That is why he can't get A blood, or she can't get A blood. Look at this interesting combination. IA-IB, that is blood group AB. This person can get AB blood, can get A blood, can get B blood, can get O blood. So you can obviously make the conclusion. If a person like this that can get A, AB, B, O, and we can get all the blood. So what does that mean? Yep, you got it right. It means he does not have any antibodies. So let's look at that way. He has no antibodies, because he's got A and he's got B. And the last blood group is blood group O, and you can see in a genetic problem when you learn about it, it's denoted with two small i's because it is recessive. We'll worry about that later. And this person can only get blood from blood group O. In other words, what does that mean to us? What does that mean to us? It simply means that this person has antibodies for what? A and B. So therefore, this person can only get blood group O. As you can see, all blood groups can get blood group O. All the blood groups can get blood group O. So O is considered to be the universal donor. Universal donor. And because AB can accept all the types of blood, it is considered to be, if you have AB, you are considered to be a universal acceptor. That means you can get any blood. But remember, there is another part to this that we need to consider, and that is the rhesus factor. The rhesus factor is a factor that is either you have it or you don't have it. If you have it, you are positive. If you don't have it, you are negative. Now, that is not just as A and B and AB and O are important, the positive and the negative are also important, especially if you are negative. If you are negative and you get blood that is a positive, you're going to the blood will clot and you can have complications. There's a nice explanation about this. When you do genetics in grade 12, you learn more about how this can affect pregnant women if they are negative and they marry a man who is positive. So when the rhesus antigen on the surface of the red blood cell is present, we say it's Rh positive. When it's not there, we say it's Rh negative. And as I said, it can cause problems during transfusions, pregnancy, and birth. And you'll learn much more about that in the next system. We move on to the lymphatic system. And the lymphatic system is made up of fluid in the human body where tissue fluid becomes lymph as we will know it. So what are the fluids that we find in our body? We find blood, where we have plasma and cells, we have tissue fluid which bathes the cells, and we have lymph fluid which drains excess fluid and carries fats, and also takes away waste from tissues all over the body. And if we look at this diagram here, you will see very nicely the lymphatic system in this line diagram that you see. Important structures in the lymphatic system are obviously the lymph nodes, the lymph vessels that we can see in the diagram, and obviously some other organs. For example, the spleen is an important lymph organ. And here on the top, you'll see in this area here, in your neck area, and in the groin area, in the armpit area, you have lymph nodes. Many people call it glands, but they are lymph nodes. And we will look at the structure of lymph nodes as we go along. And all these nodes are connected with lymph vessels throughout the body. The minute the fluid goes into the lymph vessel, it is called lymph. So we start off with blood. Blood becomes tissue fluid, and the tissue fluid, if it goes into the lymph vessels, is called lymph. These are the three fluids that we are important in our bodies. As you can see, I've shown you the diagram here, and the lymph system or the lymphatic system empties out into the right and left subclavian vein, which then empties out into the heart. So all the fluid that is coming from the whole body, from the tissue fluid that has accumulated into the lymph vessels that became lymph, this fluid now travels through the lymph vessels via the lymph nodes and eventually empties out into the right and left subclavian vein, which then empties out into the vena cava, which will then enter into the heart. So that means there is a circulation of these substances as well via the lymphatic system. And you can see from the diagram also that the lymph vessels are located as a network throughout the tissues in the body. They assist the circulatory system and the cells of the body by removing waste, very important, germs and excess water from the tissue fluid. If this does not happen, then obviously the tissue fluid will remain in the tissue fluid, around the tissues, and this can cause swelling, which we'll talk about later. Lymph vessels carry lymph flow in one direction only, from the bottom of the body upwards to the heart. The valves prevent lymph fluid from flowing backwards, again, because there's no pressure there, and muscle contractions push the fluid upwards. Lymph vessels play a major role at two sites, at tissue level and in the villi. This is a diagram showing you the lymph node. As you can see, it's a system of tubes. Here's something, the afferent lymph vessel coming in here. So the lymph comes in here, it goes through all these canals, and then it leaves. So what you can compare this to? What can you compare this to? We can compare it to a filter in a fish tank, for example, or any filter in your pool. The water comes in, it moves through all the sand and whatever else you got into in that filter, and it comes out. What is the purpose of this? The purpose is to slow down the flow, and in this case, if there are any foreign particles or germs or infections, it takes them longer to go through these areas, and when they go through here longer, the body has time to develop a defense and fight this thing. This is why when you have an infection, you'll notice that your lymph nodes on the side of your throat, etc., will be inflamed. Why? Because they have trapped the infections in there, and the swelling takes place because of that. And once you get rid of the infection, then obviously the swelling will also go down. Lymph at tissue level, the arterial blood is under high pressure. Remember what we said, arteries carry blood away from the heart. From the heart, we get arteries, they're going that way. These arteries become capillaries, and then the capillaries unite to form veins. When the heart is pumping here, the blood in this area is under high pressure. When it comes here, there's lots of blood coming in here, but there's no pressure on this side, so the blood flow on this side is slow. So what happens is a pressure is created in this area here. So some of the fluid, not blood, some of the fluid, not blood again, some of the fluid filters out here. And this fluid is called tissue fluid. And the tissue fluid bathes the cell. This is how we get tissue fluid, by the way. And obviously oxygen and glucose, etc., can diffuse into the tissue fluid, and waste products can diffuse back into the blood somehow. So oxygen and glucose diffuse into the cells, and waste products diffuse out into the tissue fluid. Tissue fluid constantly drains into the capillaries, which lead into venules and then veins. So some of it goes back into the blood system, but bulk of it goes into the lymph vessels to be carried away by the lymphatic system, and the lymphatic system empties into the subclavian vein. As we said, lymph moves up the body because of muscle contractions, and we have valves that prevent backflow of lymph fluid. When a person stands or sits for long periods, the lymph collects in the feet and lower legs, causing swelling, also called edema, condition where there's a collection of tissue fluid in that area. In terms of the lymphatic system and the villi, the lymph in the villi of the digestive system, the villi are little finger-like outgrowths like that inside the intestine, and there's a large lacteal in the middle of the villus. So when nutrients are being absorbed in the digestive system, the smaller substances like glucose, amino acids, etc., they go into the blood capillaries, and that's how they transport it. Fat molecules, or small fatty acids and glycerol, they are too large to flow into the blood system, so they go into this lacteal, and the lacteal will take it up, and eventually it will go to the heart, and from the heart to all parts of the body. So fat molecules are hydrolyzed into fatty acids and glycerol. These pass into the lacteals, and the lacteals will transport them right through the body, and this will then take it to the heart, from where it will be pumped to all parts of the body. The functions of the lymphatic system. Obviously, the first one we learned, drainage of excess tissue fluid, also return of plasma proteins into the circulation, removal of bacteria and toxins, any foreign particles, transport of absorbed fat from the villus, and the manufacture of lymphocytes, which also help in the defense of the body. And that, people, is a mouthful. I'm sure you are nice and hungry or thirsty, or you want to just run to the toilet. I'll catch you after the break. Hi guys, and welcome back. I'm hoping you had a good break. Welcome back to Mindset Learn Extra, Grade 10 Life Sciences again. We are still busy with the heart and circulation. Now that we've learned about the heart, we learned about the structure, the functions of different parts of the heart. We learned about the different blood vessels, what do they do, how they are different from each other. We also learned about the lymphatic system and what the lymphatic system does to assist circulation in general. Now that we've learned all about this wonderful, most important system in our body, we also need to look at what can go wrong. So today, we move on to cardiovascular diseases. First of all, cardiovascular disorders are obviously a major cause of death in our modern society. And what are they? Heart attacks and strokes are the major guilty party there. Angina is a condition caused when the heart muscle receives inadequate supply of blood, and this can cause pain in the chest area especially. So it's a situation when the heart muscle itself is not receiving enough blood. Remember when we looked at the heart, we said that the heart muscle also needs blood, and the blood is supplied to the heart muscle via the coronary arteries, and the waste from the heart muscle is taken back to the heart via the coronary veins. So if these coronary arteries are blocked, then blood does not go properly to that part of the heart, and therefore this causes a depletion of oxygen and nourishment to that part, and this is what gives the person a pain in the chest. We look at myocardial infarction. Very big word, simply means heart attack. And a myocardial infarction is a severe heart attack that can lead to death. What are the causes? And some of these causes we looked at before. The causes are hypertension, high blood pressure, and stress. Big cause, stress. Smoking, very big cause. Unhealthy eating habits and a poor diet. Being overweight, or a condition which we call obesity. Or if there's very high levels of cholesterol in the body. In other words, this is related again to the poor diet, that if you have oily foods, etc., and this will cause high cholesterol in the blood. Also, some people are predisposed to having high cholesterol. In other words, they have a genetic condition where their body cannot break down the cholesterol, and therefore they have a high cholesterol level. Obviously, once they learn about this, these type of people will have to lower their intake of cholesterol and or go on to medicines that will help them to manage this situation. Another disease known as atherosclerosis simply means hardening or narrowing of the arteries. With this disease, fat, calcium, and cholesterol are deposited on the arterial walls. This reduces the diameter and makes the wall thicker, harder, and less elastic. Now, consider the artery to be a hose pipe. If you want to deliver water from the tap to wherever, to the car, you're washing the car, or to the lawn, and you buy a brand new hose pipe and there's no muck on the inside, obviously the water flow in that hose pipe would be smooth and nice flowing. However, if you leave this hose pipe lying around and rust from the tap gets deposited inside the hose pipe, and over time sand gets into the hose pipe, obviously this sand will harden on the inside of the hose pipe. The rust will form also on the inside of the hose pipe from the tap or wherever it came from. Whatever it is that goes there, obviously it will not allow water to flow through nicely. The same way, your artery is a vessel. Its job is to take blood from point A to point B. And obviously, if we deposit oil or calcium or any other cholesterol for that matter into this wall of the artery, the diameter of the lumen, the space, remember when we spoke about arteries, veins and capillaries, we said that the artery has a narrow lumen anyway. Now we are narrowing it even further. Now if you put your finger on a hose pipe, then you'll notice that the water will shoot out faster. What have you done? You have decreased the diameter, but you have increased the pressure. So in this way, if you are decreasing the diameter, the pressure within that blood vessel will also increase. So you will suffer from hypertension, high blood pressure as well. So what happens in this situation, apart from that, obviously blood can get caught in the cavities and blood clots form and may cause myocardial infarctions. That means a heart attack. When a patient is diagnosed with atherosclerosis, a surgeon performs a coronary bypass to remove the blockage. It could be a coronary bypass, coronary bypass. Coronary from coronary vessels, bypass is to bypass the thing. Very simple. It means we are now moving blood past those blood vessels that were blocked, and we continuing the supply of blood in the heart. Bypass, taking blood vessels from other parts of your body and they are inserting it in the heart, and the other blood vessel that was blocked will now be closed off, and this will be the new. In other words, we have created a deviation. Road is closed, we open the new road, and now you're going to go that way. Instead of going from here this way, now you're going to take a new road and the blood will continue to flow in that way. Such an easy procedure. However, that is the last step. Before we get to that step, there are a couple of other things that need to be done. First of all, how do we know whether somebody has blockages in the arteries, in the coronary vessels? One would have to do an angiogram. An angiogram, a tiny tube pushed in from the groin right up into the chambers of the heart. And this whole thing has a little camera, and you can watch this, by the way, while they're doing it to you, and eventually they pump in some iodine and they see whether the iodine flows freely or it is blocked. In those vessels where there is blockages, the iodine will not flow in properly, and therefore they can see that that vessel is blocked. Some people are lucky. While the angiogram is taking place, the blockage can also be opened up. If not, they can use what they call an angioplasty, which will solve the problem, or they can put a stent inside the blood vessel to keep it open. If all these options are not good enough, then they do the bypass. Just understand that, right? So sometimes the blockage can be removed by inserting a balloon in the artery called a precutaneous transluminal coronary angioplasty. Main word you need to know there is angioplasty. What they do there is they put a little balloon into the artery. It opens the artery up a little bit. What are the causes of atherosclerosis? Obviously, what is it? Deposition of fat, oil, calcium in arteries. So obviously, one of the causes would be a poor diet. You are not eating a balanced diet, and you are eating a diet that is full of oil and cholesterol and other unhealthy stuff. Lack of exercise is another contributing factor. And stress is another contributing factor. These are the three most important contributing factors: poor diet, lack of exercise, and stress. Guys, we have to understand that this body of ours is made up of such lovely, beautiful organs and vessels and tissues. But we need to keep it healthy. What you put in is what you get out. So if you put rubbish in, you're going to get rubbish from your body. You don't want that, do you? You want to live a normal, healthy life without any complications. So put in good and you'll get good out. Keep your body in trim condition. How? Little exercise. And exercise does not mean, guys, that you have to go to the gym and pump iron all the time or get on a treadmill and run till you die. No. Exercise is simple. Keep fit in different ways. Walk around your house, especially after you eat your meals. We have this habit: eat a meal, get onto the couch, watch TV. Eat a meal, jump into the bed, lie down. All unhealthy. When you eat, immediately after you eat, take a walk. And when you take this walk, you must walk a considerable amount. You know, some cultures believe that at least 40 steps you must take after your meal. In this way, you are helping your food to digest. After that, then you can sit and do whatever you want to. That's a simple health tip that we need to take. Immediately after our meals, take a small walk. That's one. Apart from that, walk around the block in your area once, twice, 3 times. Walk to your neighbors. Walk to school if you can. Play a little bit of soccer, netball, hockey, whatever. In that way, you will keep yourself fitter instead of sitting and only playing with the PlayStation or your cell phone, etc. Do some real sport. Go out there and enjoy yourself. In that way, you'll have enjoyment. At the same time, you'll be helping your body. And if you are stressed, deal with it so you do not have problems. We move on still. Another one, arrhythmia. And this arrhythmia, coming from the word rhythm. So something wrong with the rhythm. And if we remember, the rhythm of the heart is controlled by the SA node, the pacemaker in the heart. And so if there's a problem with the pacemaker, the heart will not beat as it should. So there's a problem with the rhythm. And how does that work? So there's abnormalities in the heart rhythm because of the SA node, the sinoatrial node or pacemaker. How do we solve the problem? We implant an artificial pacemaker under the skin to regulate the heartbeat and correct this condition. So in other words, the nervous system will not be doing this anymore. The pacemaker itself, this electronic device that we've put in, will solve the problem. It's generally caused by genetics. In other words, you inherit this from your parents, and the G generation of the pacemaker region of the heart wall. In other words, if you remember the diagram of the heart, you'll remember the thick septum running down, and that area there, just on the right side, the sinoatrial nerve, sinoatrial node was where from there the Purkinje fibers spread out, and in that way the rhythm of the heart contraction contracts at the same time. The ventricles contract together, the atria contract at the same time. So if there's a problem there in that area, the SA node, and there's a degeneration there, then you'll have problems regarding that. The other one is a stroke, very common. A stroke is a disturbance mainly in the brain function due to either a blockage in a blood vessel supplying to the brain or the bleeding out by a ruptured blood vessel causing a hemorrhage. 80% comes from the blockage, and 20% of the time it's because of hemorrhage. That means the blood vessel has burst for some reason. It can burst because of high pressure in that area, or even very low pressure in that area. The blood vessel can burst, and when it bursts, that part of the brain does not receive blood. And if it does not receive blood, that means it does not receive oxygen, it does not receive food. And the waste, the carbon dioxide, is not being taken away in time. And if this happens, obviously that part of the brain is not getting nourished, and therefore that part will be damaged. The quicker we act in these situations, in all these situations, the better it is for us to save this person, whoever it is. So we need to be aware of these little things so we can deal with it appropriately. So what happens is an obstacle prevents the oxygen and nutrients being carried to the nerve cells in the brain, and there's damage in that area, and this will obviously disturb the function of the brain and the central nervous system. Blood from the ruptured vessel with the cranium compresses the brain tissue, causing paralysis, speech loss, and possibly death. It is a major cause of disability and death among elderly people, and strokes are often associated with high blood pressure and atherosclerosis. Now, we have to be cautious about these things. So obviously, can you see that hypertension, which we spoke about earlier, and atherosclerosis that we spoke about earlier, they both lead to stroke as well. Over and above that, your poor eating habits, your smoking, standing too long in the sun without protection, these are different factors that can lead to stroke. Diabetic patients must be extremely even more careful, because for them, they may have a stroke and not even know it. A normal person will have a stroke and he would feel it because it will affect certain parts. But a diabetic, sometimes a stroke can go unnoticed. So they've got to check their blood, they've got to check their blood pressure, they've got to check their heart condition regularly. Remember, from diabetes, lots of other problems can actually appear. Because of this sugar that's high, lots of other complications can crop up. For example, kidney failure, poor eyesight, poor healing of wounds, etc. So diabetics must be especially cautious about their heart condition at all times. They need to keep monitoring their heart condition, so they should rather regularly see a cardiologist or just the ordinary GP to see whether everything is okay there. Another one there is anemia. Anemia results from a lack of red blood cells, and this can be due to a lack of iron in the diet. In certain areas, we have a condition known as sickle cell anemia, especially in areas where malaria is very prevalent. The red blood cells, which are normally disc-shaped and biconcave, are sickle-shaped. A sickle looks like this. And a normal red blood cell looks more or less like that. So we can already see from this diagram, this red blood cell has a large surface area, and because of its shape, it can squeeze in and out of capillaries. This one here, because of its sickle shape, it has less surface area, and it can get stuck in capillaries and can cause problems. So because of the situation, the person has a lack of iron in the diet, and therefore hemoglobin, remember when we spoke about compounds or chemical compounds, we said hemoglobin, globin or globulin is the protein, and heme is the iron. So obviously, if you don't have iron, you won't be able to manufacture hemoglobin, and if you cannot manufacture hemoglobin, then you will not have a taxi for oxygen. So therefore, you will have less oxygen in the blood. It will result in you becoming paler, getting tired quickly, etc. So if there's a lack of hemoglobin, the cells are not provided with the correct amount of oxygen, and therefore less respiration. Person will feel faint and weak, tired. If he stands up quickly, he or she will feel dizzy very often. The heart will also be stressed, because it must pump more blood to the vessels so that they can receive oxygen. What the hell does that mean? It simply means because there's less hemoglobin, the cells are getting oxygen less from the blood. To compensate that, the cells still need the oxygen. So the heart must pump more oxygen, or rather more blood to the cells, so that they get more oxygen eventually. But that means the heart is working more. It's taking your engine, and you are driving this car, and you need to get from A to B, but you got enough time. So therefore, you cruise at 80 kilometers per hour. But now every time you're in a hurry, you got to put your foot down and you got to drive fast. So you are straining the engine, because the engine has to work faster or more to get the work done. We're the same situation here now. Because there's less hemoglobin, this heart of yours, this engine in your body, needs to pump blood faster so that everything can reach where it needs to reach on the time. This can also cause palpitations of the heart, irregular beating of the heart. A little bit about cardiovascular disease. Someone in our history is Professor Chris Barnard, Christian Barnard as his full name, South African heart surgeon, who performed the first human heart transplant on the 3rd December 1967, a year after I was born, at the Groote Schuur Hospital in Cape Town. The recipient was Mr. Louis Washkansky, who lived for 18 days but passed away due to pneumonia with his new heart beating strongly to the end. There was nothing wrong with the heart, but he had pneumonia and he passed away. The surgery where this historical heart transplant took place has been converted into a museum in honor of these pioneers. Cardiac surgery is a highly specialized branch of surgery that deals with the heart. This is a photo of Dr. Chris Barnard, a South African. So this is an inspiration for you out there. This is a South African from this soil who had the first heart transplant done. So you too can write your name in history if you work hard enough and you use your mind creatively. During heart surgery, the patient is placed on a heart-lung machine so that the blood remains oxygenated all the time. Coronary artery disease, heart valve disease, and congenital heart defects can all be surgically treated. We spoke about the coronary bypass already, and heart transplants are only considered as a last option when the heart cannot be repaired. There are obviously there's a shortage of organs, as donors must match the specific tissue and proteins of the recipient as closely as possible. When we deal with any transplant of organs, we have to make sure that there is a match between the donor and the recipient in terms of blood type, tissue type, and the amount of proteins, etc., found in the organism. Look at this particular diagram now. As you can see, a heart is put in and they're stitching in that area, so the blood vessels of the person is connected to the heart and the heart is stitched into place by the surgeons. Another important name that cropped up with Chris Barnard is Hamilton Naki. He was a gardener at UCT Medical School, and Dr. Robert Hutz recognized his potential and asked him to take care of lab animals. With observation, watching people working, he became an expert in animals and performed transplants on these animals. In 2003, the National Order of Mapungubwe was given or bestowed upon Hamilton Naki. It's an honorary degree, was given to him because of his contributions to this. Remember that when this transplant took place, 1967, South Africa was still under apartheid rule, and therefore that's why his efforts were recognized so much later in time, after democracy reached our shores. And this gentleman, because of his color, was not appreciated earlier. In fact, lots of articles say that he helped Chris Barnard as well in his work in various different ways, and that's why he was given an honorary doctorate as well for this, and he got a very high order from the government in order to recognize his creativity and his contribution to society. Treatment of heart diseases, generally medicine. We give the guy some medication. Sometimes they can put stents. Stents keep the blood vessels open. Sometimes valves may be faulty. They replace those valves and they put in artificial valves. Bypass surgery, which we spoke about. Putting pacemakers, which we spoke about. And obviously the last one we spoke about was transplants. Remember, there are laws that control these things. If we had to just have transplants without laws controlling them, we would have a market out there for killing people so that we can sell their organs. And we hear these stories very regularly where people are killed for their body parts. So in South Africa, we may not sell organs. It is illegal to sell organs. So if somebody comes to you on the street and says, you know what, I can offer you a heart or a lung, please stay away from them because you'll end up in serious problem. Organ transplants are arranged by hospitals and the specialist surgeons based on very strict rules and regulations. Organ recipients are placed on a rating list based on life expectancy and the chances of rejection and tissue typing, and they go on a waiting list. Related donors are thoroughly screened first to ensure that they are left with a 100% functioning organ and certainty that their life will not be impacted in any way by the donation. In other words, let's say, for example, your brother or sister needs an organ. For example, you can't obviously donate your heart. If you donate your heart, you will die because you won't have a heart. But you can donate, for example, a kidney because you have 2 kidneys. You may donate 1 kidney to your brother or sister or relative where there is a tissue matching done, and you can live a normal, healthy life. But obviously, the doctors will take you for screening to see whether you would be fit and healthy after you've given this there. So they do all those screening before they use you as a donor. Remember, our ethics and belief systems are different. Some people believe that you can donate organs, others believe that you can't donate organs, etc. And we need to work around these things because we live in a beautiful country where the cultures, values, and morals of all the diverse people in our country are appreciated and accepted. Also, when you want to be on this list, you got to register on a donor list. Also, you must try to donate blood when you can, and as a donor, you can give your name, or you can be an organ recipient as well. So you can list on these things as well. With that, I think you've learned quite a bit, and I'm hoping I motivated you to keep yourself healthy, wealthy, and wise. I'll catch you after the break. Hi guys, and welcome back to Mindset Learn Extra Grade 10 Life Sciences Grade 10. We've just gone through the entire procedure of learning about the heart, the different parts, how blood circulates, lymphatic system, how that works, and also some disorders or diseases associated with the heart. You've learned all this work, we've spoken about it, you've absorbed it. Now let's see what you have learned. Let's look at some of the questions that can be asked in an exam. The first question says, study the diagrams which show 2 cross sections of mammalian blood vessels. And the first question, 1.1 here, says, which blood vessel, A or B, is the artery? This one or that one? And our answer would be B, obviously. And the catch in a question like this would always be, it's nice to say A or B. Obviously, the next question is going to be, give a reason for your answer. So here's it, provide 2 reasons for your answer to question 1.1. Why do you say that B is the artery and not A? Obviously, we look at the smooth muscle layer. So one reason would be the smooth muscle layer is, yep, you got it, thicker. And 2, because of that, the lumen is smaller. Where is it smaller? In B. Where is it thicker? In B. So that you're specifying to the examiner or the marker that you know what you're talking about. So because the smooth muscle layer is thicker in B, and because the lumen is smaller or narrower, we say that this would be the wall of an artery, and A would be the wall of a vein. So that would be artery, and that would be vein on the side. Good. Still with the same question. Which blood vessel from these two carries blood at low pressure? Obviously, it would be A. The vein carries blood at low pressure. Provide one reason for your answer to 1.3. Why did you say that the vein carries low blood pressure? The reason being, vein is not under direct pressure from the heart. The vein is not under direct pressure from the heart, therefore the blood pressure there would be lower. Simple. Simple here now. Identify. Simple level 1 question. Identify parts numbers 1 to 4. Remember, it's saying 1 to 4. So that means 1, 2, 3, 4. If it said 1 and 4, then it only be 1 and 4. So please make sure you understand the difference between these two. So 1, obviously the outer connective tissue. 2 is this innermost layer, and that is the endothelial layer. 3 is this area here, the gray area, that will be the smooth muscle. And 4 is the space on the inside, and that is the lumen. So from the in connective tissue on the outside, followed by the smooth muscle in gray in both cases, followed by the white line in both, which is the endothelial layer, and the space in the middle, the lumen in both. So both of them have all of these characteristics. Still with this, how do capillaries differ from larger blood vessels? How do capillaries, in other words, differ from the veins and the arteries? And it's very simple. Capillaries have a single endothelial layer only. You could say that, or you could say that the capillaries do not have the smooth muscle and the connective tissue layers. It means the same thing. If you say they only have the single endothelial layer, or you say that the capillaries do not have the smooth muscle and the connective tissue, it would mean the same thing. That is how they are different from arteries and veins. Still with the same question, in which vessel, A or B, would you expect to find valves? Now, something that just hits my head now at the moment as I'm talking about this question is V is for veins and V is for valves. So therefore, you'll remember that veins are mainly found in valves. Valves are mainly found in veins. There are exceptions to this, in that the aorta and the pulmonary artery have valves, but all other arteries do not have valves. But mainly the veins have valves. Why? To prevent backflow of blood in veins. So your answer then would be A. You can't say veins. You cannot say veins. Why you can't say veins? Because the question said which vessel, A or B. Or they could say write down the letter of the vessel. In that case, remember, you've got to give the letter and not the name of the vessel. Still with that question, what is the function of the valves in question 1.7? Obviously, to prevent backflow of blood. Simple. Still with that question, name the blood vessel that carries deoxygenated blood from the heart to the lungs. Deoxygenated blood from the heart to the lungs. It is the pulmonary artery. By the way, it is the only artery that carries deoxygenated blood and carries oxygenated blood from the heart for systemic circulation. That would be the big one, aorta. Carries blood from the digestive system to the liver. That would be the hepatic portal vein. straightforward, just naming blood vessels. Recall, you didn't need the diagram for that. This is not related to the diagram. It's just unrelated. It's related to the work that is covered here. And we move to question 2. Question 2's got a diagram again. Study the diagram of the lymphatic system and answer the questions that follow. And there's a nice diagram of the lymphatic system. It says, name the components of the lymphatic system. In other words, what makes up the lymphatic system? Obviously, it would be lymph itself, the fluid. Then obviously the vessels, lymph vessels. Then you will have your lymph organs. You'll have your lymph nodes. Depending on what the examiner wants, you can even add your lymphocytes. These are some of the things that you will find that make up the lymphatic system. Depending on what the examiner wants, you can write any 4 of these. Next question. Identify the blood vessel number 3. This one here. Look from which side of the heart it's coming. It's coming from the right side of the heart. So it would be the pulmonary artery. It's coming from the right side of the heart. If it was coming from the left side of the heart, it would have been the aorta. Good. Duct number 4. This duct here in the lymphatic system, if you remember the diagram, that was the thoracic duct. And structure number 6, these little swellings all over, these are known as lymph nodes. Structure number 6, we got already. Good. We've covered that question. Let's move on. Name 2 factors that assist movement of the lymph fluid. What factors assist the movement of the lymph fluid? It would be the muscle contraction and the presence of valves, because the valves will prevent backflow. The muscular contraction would move the lymph upwards. State 4 functions of lymph in the human body. We discussed all these functions earlier. We looked at all the functions of the lymph. One was obviously to drain waste products from the tissue fluid back to the heart, and from there get rid of it from the body. Another one was obviously to return plasma proteins back to the heart and into circulation. The third one was to transport fats from the villi to the heart and then to all parts of the body. Another very important function of the lymphatic system was to trap and remove bacteria and toxins from the body. So let's write those things down so that you can remember them. Number 1 would be to drain excess tissue fluid back into circulation. 2 would be to transport plasma proteins back to circulation. 3 was to transport fat from the villi to the heart. 4 was to trap and remove bacteria and toxins. And 5 was to manufacture lymphocytes. This function here would be related with the one above as well. So those are the functions of the lymph in the human body. Now we have a different question, and the question is a paragraph that you have to read and you need to answer questions related to this article. This article, by the way, appeared in on the website of www.health24.com. The article, just to read very quickly, the latest figures from the Organ Donor Foundation show that there are currently over 3,500 South Africans waiting for organ and tissue transplants. Sadly, as a result of this critical shortage, less than 1,000 of them will receive a transplant and the gift of life in 2009. In South Africa, in 2007, there were 688 organ and cornea transplants. Exactly 288 of these were solid organ transplants broken down into the following. And they give you a whole range of figures. Hearts, these are now organ transplants. 24 in adults and 2 pediatric, 2 children. Heart and lung together, 0. Lungs alone, 7 adults. Livers, 24 adults, 2 adolescents, and 9 pediatric. So teenagers and 9 children, small children. Simultaneous kidney, pancreas, 10 adults. These transplants were all carried out in Johannesburg. Simultaneous kidney and liver, 1 pediatric. Kidneys alone, 195 adults, 7 adolescents, and 7 pediatrics, of which 57 adult, 7 adolescent, and 7 pediatric transplants were related. 14 adult kidney transplants were non-related. 34% of the kidney donors were related to the recipients. And 356 adults, 29 adolescents, and 15 children had their sight restored through a cornea transplant. So they give you a whole article that you needed to read. So this is the data provided to you. Data response question. You need to read the article properly, understand what the article is talking about, and then go into the questions. Let's go into the questions. They say, what percentage does heart transplant constitute among total transplant done in 2007? Now, one could look at this question in 2 ways. First of all, obviously, you've got to go back and see how many heart transplants were done. And there were 24 plus 2 is 26 heart transplants were done. And the question is saying, in the total transplant done in 2007. Now, let's say, for example, we were only talking about the total organ transplant. So if we add up all the organ transplants just on their own, we will add all those figures, we'll come to a figure of 277, I think. And if we work out, the question says, what percentage of that is the heart? And I said 26, so we're going to say 26 divided by 277 times 100, or on your calculator, you simply press the percentage button, and that should give you a figure of about 9.38, more or less. How many of the kidney transplant recipients received kidneys from their relatives? Go back to the paragraph. The paragraph says 34% of the kidney donors were related to the recipient. And we go back to, and how many were altogether done? 195 plus 7 plus 7, that will give us a figure of plus minus 209 times 34%, or 34 divided by 100, and that gives you 71 plus minus. Suggest possible reasons for the huge backlog in the number of transplants. We've spoken about this earlier. Why is it that people are still waiting for transplants? One would obviously be because of culture and ethics, etc. Many people don't donate organs. So there's a shortage already because there's not enough donors. Secondly, there will be a problem because of lack of matching a donor to the recipient. So we have those two problems there. Draw a pie chart to show the percentage adults who received heart, lung, kidney, and liver transplant in 2007. Now this is a bit of a tricky question, because you'll go through the totals and so on. They're only talking about heart, lung, kidney and liver. So we need to take those figures and we need to add them first. So we have to go back again to the article. And the article said heart 24 plus 2, that's 26. The heart was 26. We write that down. 26 were heart. Then lungs, there were 7. Livers, 24 plus 2 is 26, and 9 gives you 35. So that gives you 35 lungs, or livers, sorry. And kidney, simultaneous kidney, pancreas, we're not interested in that because we didn't ask about that. We didn't talk about simultaneous kidney and liver. We spoke about kidneys only. So 195 plus 7 will give you a figure of 209. We worked that out just now. So those are our figures: 26 hearts, 7 lungs, 35 livers, and 209 kidneys. Let's go back to the question. They want you to draw a pie chart to show the percentage adults who received these things. So the total of that is, we must add those things there. It comes to 277 altogether. If we add 26 plus 7 plus 35 plus 209, you'll get a total of 277. So for each one, we first have to work out the percentage. And the first one is 26 out of 277 times 100. The second one would be 7 divided by 277 times 100. The third would be 35 divided by 277 times 100. And the fourth one would be 209 divided by 277 times 100. So that's our figures. So we're going to work out on the calculator these figures, and your answers would be, the first one would give you plus minus 9.38%. The second one should give you a figure of 2.5%. The third one should give you a figure of plus minus this one here should give you something like 75.4%, the one on the kidney. And the livers were 35, so 35 divided by 277 times 100, and that gives you a percentage of plus minus 12.6%. Now you need to go a little further, because you need to plot a pie chart, and a pie chart is based on a circle, and a circle is made up of an angle of 360 degrees. So you're going to take these percentages and convert them into degrees. Now I'm going to do this very quickly for you. The first one there, 9.38%, which gives us an angle of plus minus 33.8 degrees. The second one of 2.5 gives us an angle of 9 degrees. The third one of 12.6% gives us an angle of 45.3 degrees. And the largest lion's share there, the angle is 271.4 degrees. If you work it out on a calculator, you'll get those figures. Now, if we add this, you'll notice that we're going to be one short. So we've got to then obviously round off. This one must become 34 to work it out easily. And these two here, one of them will become 46 and the one will come 271, and you'll work out that way. It doesn't matter which one of these you change, it won't make a difference as long as your total must come to 360 degrees. And obviously thereafter you're going to take a protractor. First of all, you'll take a compass, you will draw a perfect circle. Then you will take your protractor and you will mark off these angles, and you will work it out on the diagram, and you will use something to show the different angles. Just to give you a rough idea, you will have a circle, obviously not like mine, it's not much of a circle, and in the circle we have 4 areas. So we're going to divide this into 4 different, hey, that's a rubbish diagram. So we're going to draw that circle with a protractor, and we're going to take our compass, and we're going to measure out, and we're going to get something 1, 2, 3, let's say 4. In that way, we're going to draw a pie chart. Now, when we're drawing this pie chart, we can't just leave it like this. Remember, firstly, it must be drawn a perfect circle with the compass, measure the angles with the protractor, work it out, use a ruler to draw the lines, and then you label each slice. One would be, for example, kidney, the one would be the lungs, the one would be heart, and the other one would be liver. Obviously, mines are not drawn to scale. I haven't used a protractor, but you would use a protractor to do that. If you do not want to write the names on the pie chart itself, you can then put in shades, etc. You can shade it, you can do whatever you want to in the different ones, and then you make a little key. That is the heart. Dotted line, that one there is, for example, the kidney, and the stripes are lungs, and the one that's clear, or let's just say call it A, we call A, and we call that the liver. So you will do that. Remember, there is a rubric that the marker will use to do this, and generally we would then make a copy of the graph pie chart on a transparency, and we will put that transparency on top of your graph, and we will then mark it correct or incorrect. So make sure that you use accurate diagrams and you use a sharp pencil to do this. In the exam, you are allowed only 1 pencil line thick deviation from the actual figure. Make sure your pie chart has a heading. In this case, pie chart showing the percentage of heart, liver, kidney, and liver transplants over time, or in 2007 in Gauteng. You will have your heading. Remember, you must have both your variables, and you must stipulate the time and the place, etc. Your heading must be full. So that you will get marked for. You'll get marked for drawing a pie chart if it is drawn in a circle, and you will get marks for your labeling your charts, your pie, your slices, and obviously you'll get the giant share of the mark is for your proportion of your slices according to the angle. And you will get a mark for the calculations. So please make sure that you do the calculations first, then you convert to angles, and then you draw the pie chart, because everything here will give you marks. That was a higher level question and a skilled based question. So you know also how to draw pie charts, you know how to use the equipment necessary to draw pie charts, etc. Make sure that you study these things well and you do well in exams. With that, I leave you till the next time we meet. Thank you.